Hello everyone, this is another student's quest, and this question I received from Somalia or Somalia. I don't know what the correct pronunciation, sorry for that, from West Bengal. So the question says that Sn is equal to summation k goes from 0 to infinity because the upper bound is not given, and this is standing for n plus k c2k and n to the power n minus k, and there's another iteration relation or recurrence relation is given in between Sn, Sn minus 1 and Sn minus 2 for n greater than or equal to 5. We have to identify or find out the values of a and b, and then we have to find out a square plus b square. So how we can start this solution? So before that you see the solution, I request you to just give an attempt and then you can see the solution. So for that, what we can see that since this relation is starting from n is equal to 3 and here n is equal to 5 from where it is starting, if this thing I can use 2 times, means I want to create 2 linear equation in terms of a and b to find out the values of a and b. So first what we do there is let's substitute n is equal to 3 there and see what is happening. So substitute n is equal to 3, so S3, and I have already calculated, so I will refer that so that at least I will present faster. So this is going to be the summation k goes from 0 to infinity, and this is not written, this infinity right there, and this will going to be 3 plus k because n is equal to 3, I'm writing c2k and 2 to the power 3 minus k. When you write this will be easier to find it out, and so we get 3c0, the first term, because k is 0, 3c0 to the power 3 plus 3c2 you get, not 3c2, 4c2 you get, because you are substituting n is equal to 3 and k is equal to 1. So that will give you 4c2 and 2 to the power 2, then 5c4, that is 2 to the power 1, and finally 6c6 to the power 0. And when you calculate this whole thing, you will get 8 here plus 24 plus 10 plus 1, and that will give you 43. So this is the value of S3. Similarly, we can find out the value of S4, S5 and S6. So let me just write all this quickly. So S4 is going to be summation k goes from 0 to infinity, so and this is going to be 4 plus k c2k and 2 to the power 4 minus k. Now if I just substitute all these values, what we am getting is 4c0 to the power 4 plus 5c2 to the power 3, then 6c4 to the power 2, 7c6 to the power 1, and 8c8 to the power 0. And if you calculate each of them, that will give you 16, that will give you 80, that will give you 460 rather, then 14, and then 1. This will give you 171. Just be hold, keep patience. I'm going to uncover all these things, and also I'll give you some smarter way. So S4 is there. Now S5, if you go through the same process, what you get is 683. So I'm not going to write all the details, but you know what they have to do. And then we get S6, and S6 when I evaluate it, I get 2731. It's a very giant number. So these 4 numbers I will get, and this is one of the way we can do. What we can do now, let's see. Since I know there is a relation between, so what I know, since I have this thing, 2Sn is equal to A Sn minus 1 plus Bsn minus 2. So we substitute this value. Suppose I'm substituting n is equal to 5 because it's starting from 5. So for n is equal to 5, the equation itself tells that actually this will give you S4, this will give you S3. So what I'm getting here is this side 2S5 and this side is A times S4 plus B times S3. This is nothing but 2S5, S5 already we have found, so 683 into 2 I have to write on the left hand side, and this what I have evaluated is 1366, yes, 1366, and this is S4 we have already found, that is 171, so this will give you 171A, and S3 is already we have found 43, so 43B. So that is going to be the first equation. Similarly, what I do, I substitute n is equal to 6. So this will give you 2 times S6, A times S5, and B times S4. And so what I'm getting this side is 2 times S6, and notice that what is going to be here. S6 is 2731, so 2731 into 2, what I calculated is 5462. So 5462, and this is going to be now 683A because yes, and 171B. Now all that we have to substitute the value of B from the first equation to B, second equation, or vice versa, whatever you want, means we have to solve these two equations. So I have calculated this thing, and this is a very giant calculation. And what I'm getting at the end, so let me just show you what I have done. So B is going to be, I've written first the B value as 1366 minus 171A divided by 43. So this is the value I got from the first, and substituted there. So we have 5462 is equal to 683A plus 171, and B is this thing 1366 minus 171A and divided by 43. All that we have to keep the trust in our calculation and do the calculation boldly. Now after that I simply multiply with 43, not simply but still. So if you multiply this 5462 with 43, and whatever calculation after this we get is going to be 1280 is equal to 128 times A. It's a very like a difficult calculation, but I don't suggest it to do it. I will give another method. So that is going to be 10 here. So A is 10, and once you substitute A is equal to 10 anywhere in this first or second equation, I will get B is equal to minus 8. And so the A squared plus B squared is equal to 164. This is one of the way we can do it with just following everything legally. Means whatever they are asking there for n starting from 3 and n greater than 5, we are just keeping those values and finding it out. Suppose I would have done by substituting n is equal to 1 there, then you will be asking that why we are doing, because n is starting from 3, so why you can substitute n is equal to 1. But the good news is this is only giving for the like this, to get this hold. Actually they don't want some what we call lower numbers, or maybe they want to confuse you, but believe me, it is also true for n is equal to 1 and n is equal to 2. So I will calculate this for you. So you know that already we have found S1, S2, S3, S4. So what we can do better is I will have S1. So S1 I have already found because I need only n is equal to 1, and after that we have to substitute these values. So what I found S1 is going to be 3, and you know that S1 how do you find? So this is going to be k is equal to 0 to infinity, and I have to put there n is equal to 1, so 1 plus k c 2k, and that is going to be to the power 1 minus k. So from there you will start adding. So first term you get 1c0 times 2 The second term you get 2c2 times 2c2 times 2 to the power 0, and after that it will vanish, so it will give you 2 and this is 1, so 2 plus 1 3. Similarly, what I get S2 after similar calculation, I'm just writing that is going to be 11 if you calculate this thing. So now we know that I have S1, S2, S3 is already we know this is a little bit better, 43, and S4 also I know that is 171 perhaps. What is that? S4 is 171. So that is better one we have. The setup will be going to be like this. We write there 2s3 is equal to as2 plus bs1, and from there 2s2, this will give you what, 43 into 2 86. So 86 is equal to 11a plus 3b. This is one equation, and the second equation is going to be 2s4 is equal to as3 plus bs2, and that also I have calculated, and I'm very bad at calculating, you know that. So 342 is going to be 43a plus 11b. And notice after solving these two, this is a comparatively easy equations to solve, and we get the answer that a is equal to 10 and b is equal to -8. So this is valid for n is equal to 1, 2, 3 and all. They have just given the iteration starting from n is equal to 5 for some different purpose. We don't have to bother about in this kind of situation, and we in both situations we get the same answer. So better you could start from n is equal to 1, 2 and 3. But the real fun starts here, and here I suggest the students who are interested to explore mathematics beautifully and to explore the deeper insight of the generating function, then only they can continue watching this video after this. Otherwise they can leave the video, because now the solutions are going to be harder and some deep thinking is required. So this is the third method, you can say, or maybe the second method, in which we are using the concept of generating function. So generating function. What is generating function? We are actually generating a function to find out this Sn actually. So suppose by any chance I get the Sn itself, I can use it here and try to structure this recursion relation in such a way that we can compare the coefficients of some like terms from the left and right. So to construct the generating function is in itself a kind of a mathematical depth. So let's deep dive. So the idea of generating function is that, so for that I will refer the note, because many such things are there, so I don't want to mess up with calculation. So let's suppose I am taking the generating function gx in such a way that I'm calling that n is going from 0 up to infinity, but I'm calling the Sn as the coefficient of x to the power n. Means suppose if anyhow I will try to find the gx itself, the Sn will be nothing but the coefficient of xn in this expansion. So let me write this thing in words, like Sn is nothing but the coefficient of x to the power n in the expansion of gx. So let's write it, the Sn itself there, and then see what will happen. So the gx again I can write there by substituting the value of the Sn itself. So I can write the summation n goes from 0 to infinity, and again I can write summation k goes from 0 to infinity, and there's a n plus k c 2k, and this is 2 to the power n minus k. By the way, you notice that this is the Sn I have written, and into this x to the power n. Now notice there that this summation sign, the inner summation sign, you can see that it is actually dependent on k. But in this summation format, I can swap the summation. Once I swap, the inner summation will depend on the n only, so the k will be taken out. So what I mean to say, let me just perform it. So this I can write like this, summation, or let me write summation, k goes from 0 to infinity. I'm swapping the summation sign, and this is going to be summation n goes from 0 to infinity, and this is n plus k c2k. And notice that this term I can write, or this part of the term I can write like this, 2 to the power n into 2 to the power minus k, and 2 to the power minus k I can write 1 by 2 to the power k in the front, because now it is not dependent on the n anymore, because for that index is k here, which is the outer summation sign, but here this is only the inner for the n, and this is n, by the way, so I will attach with this. In this, what will happen, that I can combine this thing, the inner sum, this one, and I'm going to perform all the operations of the inner sum first. So let's call this thing the is, like this, the inner sum. So I'm calling this is here inner sum, and there is going to be summation n goes from 0 to infinity, then n plus k c2k, and this I can combine together, so write 2x to the power n. Now from here, what I can do, let's see. From there, what I'm going to do, I'm trying to change this index because it's a little bit difficult for me to manage. So I'm going to write the new variable m, which is n plus k. So if m is equal to n plus k, you see that what will be the effect of this m is equal to n plus k on this summation. When n was 0, the m will become k. So I can write the m is starting from k and going to infinity, but n plus k will become m, and this is c2k, and here 2x to the power n is going to be m minus k. What is the benefit of it? Let's see. The benefit of it is this one, that m is equal to k there is infinity, and again I can write m c 2k, and this is going to be 2x to the power m, and again I can take here 1 by 2x to the power k, 1 by 2x to the power k. Now what is this thing? We have to be careful to understand. So if you can guess, you can pause the video here and see what is this quantity. If you research in depth, actually this is going to be, I'm writing this thing first, I'm taking this bracket there, and here research means you have to just explore the mathematics, not the kind of a research of researcher. This is going to be 2x to the power 2k and divided by 1 minus 2x to the power 2k plus 1. And from where it is coming, let me also explain this thing. So what I have written so far, let me just clarify this thing. What I have written is this one. This summation, I'm going to write, this entire thing I'm going to write as 2x to the power 2k by 1 minus 2x. Let me also confirm it and correct. Yes, that's correct formula. Yes. So my memory works. So 2x to the power 2k and 1 minus 2x to the power 2k plus 1, and this I left out as it is. But why it is coming like this, that is also very interesting thing to notice. So what I can say, Now this time, at this moment, at this point, my task is, the goal is to prove this thing. What do you have to prove? This summation, what you see here, let me copy it and paste it here, and that is equal to, I have to prove that is equal to this quantity, 2x to the power 2k divided by 1 minus 2x to the power 2k plus 1. Again, you can pause the video here and digest everything what you have learned so far. I hope you are smart enough to understand all these things. That's why you are watching at this moment. Now, I have to prove this thing. So for that, if you can prove from here, that will be super. I appreciate. But if you don't, let's proceed. So for that, what we assume, so what we consider this thing as a very interesting. Consider, I'm writing the summation of, let's say any n goes from 0 to infinity and any u to the power n. You notice that this is a geometric series starting from 0 going up to infinity. So the first term will be 1 and the common ratio will be u itself, and the number of terms will be infinite. So what you can write for this, we can write this as 1 by 1 minus u, the sum of infinite GP. Now let's, let us start differentiating this thing. So first I take the first derivative. Let me write first derivative. So if I do the first derivative, I'm getting here summation n goes from 0 to infinity, n into u to the power n minus 1, and here I get minus sign because 1 by 1 minus u the whole square, but again there is a minus in here, so I will get the plus back. It means that what I'm getting is 1 by 1 minus u the whole square. Now let's do one more time the derivative. So let me write here second derivative, and I'm writing this, all the derivative things in the words also, there's a meaning of it, we'll understand it. So summation n is equal to 0 to infinity again, but there I get n into n minus 1 and u to the power n minus 2, and here 2 divided by 1 minus u to the power 3. You notice no minus sign will come again because there is a minus is sitting here, and that will make every time the terms positive. Now the third derivative again I want to do. Third derivative, again you differentiate. So what you get is n minus 2, rather let me write in this way, n into n minus 1 into n minus 2. So n minus 1, n minus 2, and u to the power n minus 3. And that is going to be 2 into 3 on the top. And I can also append there 1, and here also I can append that 1, and that was 1 only. So now you can actually notice what I'm going towards. That is 1 minus u to the power 4. Can you identify the pattern, or do you understood what I mean to say there? I hope you understood. So what I'm going to do is, here, if I just proceed this thing and I went to the rth derivative, let's say rth derivative. So let's decode this thing. How do we decode this? See here. When you've taken the first derivative, so this is the first here. So notice what is happening. There is 1. Again, maybe you, and this power will be 2. Let's try to understand the same pattern. Here the first derivative, there is a 1, 1 and 2. All right. Now if you go to second derivative, I have this thing, second, so 2, then this is 2 factorial, this is 3 actually. But also notice where this thing is stopping. This is stopping at 1 because the second derivative stopped at 1. Now here third derivative is stopped at 2. So can you tell me what I write for the rth derivative. I will write, and by the way, one more thing I actually want to tell you, that intentionally I wrote this n is equal to 0, but this is not n is equal to 0 actually in here. Why? Because you notice when you substitute n is equal to 0 in this equation, or sorry, this term here, the first term will become vanish. So there is no such actually requirement to write n is equal to 0 there. So I can write this n is equal to 1 here. Then the second time, means the third time you differentiate there, sorry, this is starting from here only, sorry for that. So n is equal to 1 there, and this starts from n is equal to 2. And for n is equal to, in the third derivative, the n should start from 3. Why? Because you substitute n is equal to 1 or 0 or 2, all the three terms will become 0. So there's no need to write that thing. Even if you write, there's no actually what we call the effect of it on the entire summation. So the rth derivative, now we can see what is happening. I can write n starts from r, because for the third derivative the n was starting from 3 and it goes up to infinity. And since we have already decoded that because there were 3 here, the third derivative, now this third derivative, this factorial type of terms, the consecutive terms start at one term before. It means I can write here n minus 1, n minus 2 till n minus r minus 1, because this is the rth derivative. And here the u to the power, the same r there, so n minus r. On the right hand side, the similar effect, because this was 3, so I can write here 3 factorial there, 3 factorial, this was 3, so I can write here r factorial, and here 1 minus u to the power, one term extra, so r plus 1. All right, now I have to just transform this entire thing in the factorial way. So you notice what I can do, what we can do from here to make it factorial. So before that, I want this u to the power, let's say I'm adding u to the power r both sides, means multiplying u to the power, because I don't need this minus sign. I don't need this minus sign. So what I'm going to do is, let's see here, summation n goes from r to infinity, and this is, let me write it, after that we will manage, n minus 1, n minus 2, okay, and then till n minus r plus 1 I can write now, and this is going to be u to the power n, and here it will become u to the power r into r factorial, and divide by 1 minus u to the power r plus 1. Now it's already over. You can see this, what is happening here. I can divide now the entire equation by r factorial, and once you divide by r factorial, so notice what is the consequence. This will give you r factorial, and here I have already r minus 1 factorial is missing. Here already n minus r factorial is missing. You notice n minus r factorial, and here I have r factorial, so I can multiply and divide by n minus r factorial, and so I can directly write that as, so I'm writing directly this entire thing. I can write summation n goes from r to infinity, n c r u to the power n, and this is going to be u to the power r, because r is already gone, and 1 minus u to the power r plus 1. So don't you think this is similar structure is there in our question? Here you notice this thing, this is standing at the place of m, so let me just copy that thing side by side so that you can relate this thing. So this is going to be copied. There's also a step of calculation. So this is going to be there, and here you can compare. So you can ask that what this is actually m is equal to k there, and this is 2k. So I'm writing. You can notice that if m starts from k and it until reach the m value will until reach the value 2k, all the values will become 0. So even you start from k, as I spoke in this situation, similarly this mc2k, because this ncr is defined only if n is greater than equal to r. So k is of course all the natural numbers we are considering. So k is of course greater than lesser than 2k. And so if you start m with k, so next will be k plus 1, then until we reach k 2k, all the terms will be 0. So technically this is nothing but m is equal to 2k. Still, when you are writing this m is equal to k, it is m starting from 2k. So therefore this formula is correctly fitting there to use, and so we can write this thing. So after writing this thing, if you are able to solve, then you can again pause the video and try to solve further. Otherwise, I am here to solve for you. So we have already got this thing. So let me just copy this thing and we will proceed. So what I got the I is this one. So this was the internal security, means internal summation. And that internal summation I is, I have to substitute in the whole summation, which is gx. So where I have to keep it, that was there. So let me take the gx again. So this thing also I want to take it. All right. Okay. If you are patient enough to persist with me, that is good sign that you love mathematics. So this is gx I have, and I'm going to substitute this thing there. So I get it what summation k goes from 0 to infinity 1 by 2 the power k, and this guy I'm writing there as 2x to the power 2k divided by 1 minus 2x to the power 2k plus 1 into 1 by 2x to the power k. So from here what I'm getting the gx a little bit in simplest form is going to be summation k goes from 0 to infinity, and this 1 by 2 the power k, and notice this is already cancelled one of them. So I'm getting here is 2 to the power k x to the power k, and in the bottom what I'm writing is 1 minus 2x to the power 2k into 1 by 1 minus 2x. And why I'm writing this thing, it will be revealed very soon. Just behold. So that is going to be, this thing get cancelled, and now I can write 1 by 1 minus 2x out of this context because there is no such index of k, and this is k goes from 0 to infinity always there. So x by 1 minus 2x the whole square to the power k is there. Now notice that this is nothing but a GP again. Why? Because this term you are writing infinite number of times with multiple of k, like this k is actually giving the multiple. So k is equal to 0 the first term, the 1, the second term will be the square of it, the third term will be the power 3 of it, and so on. So this is going to be the summation I'm going to write for it, and this is the first term is 1 and 1 by 1 minus r. So r is going to be x by 1 minus 2x the whole square. The good thing is that 1 minus 2x and 1 minus 2x get cancelled, but 1 minus 2x will jump on the numerator, and that is going to be 1 and plus 4x square minus 5x. Yes, so 1 plus 4x square minus 5x. Now the other story is there. We how do we write the gx in the form of a series? So to write this kind of ratio or the rational functions in the series, we will use the partial fraction. So first of all, we will make this thing factors. So I've already factored it. Let me write it quickly. 1 minus 4x and 1 minus x. No? Yes. So now my intention is to write 1 minus 2x by 1 minus 4x into 1 minus x into partial fraction, and you know how to write. So a by this you have done in the this thing integral calculus to find the integration by partial fraction. And since I have already calculated, I will write for you directly so that I can conclude this long video, which is not suitable for many such good students also. This is going to be 2/3. I have written there. Let me just zoom in. This is 2/3 1 by 1 minus 4x, and then plus 1/3 1 by 1 minus x. Now if you tell that where we got the n and all those things, so gx I got here is 2/3 1 by 1 minus 4x and 1/3 1 by 1 minus x. And now you can notice again that this is again the sum of infinite GP, and with the first term is 1 and the common ratio is 4x. So I can write this 2 by 3 into summation of n goes from 0 to infinity 4x to the power n, and this is going to be 1/3 summation n goes from 0 to infinity x to the power n. If I ask you that what is the coefficient of x to the power n, because please notice in our generating function when we started this whole drama, our aim was to find the coefficient of x to the power n. So if we ask you what is the coefficient of x to the power n here, so what is your answer? So coefficient of x to the power n is going to be 2/3 into 4 to the power n from the first summation, and 1/3 of nothing because this is 1 there. It means our Sn is nothing but 2 into 4 to the power n plus 1 you divide by 3. Now this is your Sn. Just let's verify it, and also we go to the answer. You notice that we got S1 in our previous method as 3. If you put n is equal to 1 there, what do we get? There's 4 to the 8 plus 1, 9 by 3, that is 3. So this is our Sn. Now let's go back to the question. The question they asked already, the 2 Sn is equal to a Sn minus 1 plus b Sn, and I have to find out a and b. Directly we can do it from here once we get the Sn. By the way, this is Sn minus 2. So what I write there? I write this twice of 2 times 4 to the power n plus 1 divided by 3 is equal to a times twice of 4 to the power n minus 1 plus 1 divided by 3, and this is 2 times 4 to the power n minus 2 plus 1 divided by 3. Now this 3 and 3 will get cancelled. I already told that we can compare the values of a and b, and by the way there's a b there I left out. I missed to write, so I'm writing this b here. Now this I'm writing as it is. So 4 into 4 to the power n plus 2, and here I am writing 2a, and this is 4 to the power n by 4 plus a, and then again 2 into 4 to the power n by 4 squared is b, and plus b. What I'm going to do now is I'm collecting the terms together to compare the coefficients of 4 to the power n and the constant term. So 4 into 4 to the power n plus 2, and here I get a by 2 plus this is 16, so this is going to be 2 by b by 8 is the coefficient of 4 to the power in the right, and the constant term will have a plus b. So now we compare the coefficients of 4 to the power n with coefficient of 4 to the power in the right hand side and the left hand side as well. So we get it here, a by 2 plus b by 8 is equal to 4 and a plus b is equal to 2. So from there I can write here that is 4a plus b is equal to 32 and a plus b is equal to 2, and by solving this 2 we get a is equal to 10 and b is equal to minus 8. Oh, so that was a very difficult calculation I have done, and it took me like here I got stuck. If you can notice that this the stuck point there, that how do we write this internal summation there. So then I struggle a lot here, and then I came to this conclusion. So because when you studied a lot of things, it is actually in your memory somewhere, but when we try to struggle and link one with another, of course this will come to some point. So this was the solution. By the way, I don't suggest the third solution, the generating function solution, in any exam. You should do the better approach or the previous approach. If the calculation is easy for you, this kind of difficult calculation also, you can do it. So that's all for today. See you in the next video with some other interesting question. Stay math active.